So, Michael, we're going to talk about Thesis 30, and I realize that Thesis 30 is part of two theses that are very important, and I see Thesis 30 as being, should we say, the discovery of the big equation here. I'll leave it at that. And then in 31 we're going to look at how that actually applies to the real world. So could you give me a sense of, what is the E equals mc squared version of evolution as it applies to how we understand aging?
Well, the analog of E equals mc squared for aging are Hamilton's forces of natural selection, the two of them. What I'm drawing attention to in number 30 is actually an interpretation of those equations. For example, an early interpretation of E equals mc squared was the realization that this implied that converting a small amount of matter into energy was actually going to release a huge amount of energy. So small amount of mass converted into energy, huge amount of energy, thus atomic bombs. In the same way, in thinking about the forces of natural selection, I came to the following insight, which is that if in fact there is no aging process, if it's an illusion like relative motion and the sunrise and sunset, you're led to the view that aging only happens because of the period during which the forces of natural selection fall. But that fall comes to a stop, and the forces of natural selection stabilize, and they stabilize for all subsequent ages. That leads to the possibility that if that's what aging is, namely an effect of the falling forces of natural selection, the fact that those forces stop falling eventually means that it's possible, it is at least conceivable, that aging itself could stop at much later ages.
That really is a wow, isn't it? I mean, that is like thinking of space-time rather than gravity as being just something big that pulls me towards it.
Right.
It changes everything, doesn't it?
And it really does, and you can only sort of go down this road if you're willing to embrace what I think of as genuine science, what some might call Popperian science, the idea that you propose a formal and daring theory, which you ideally process and analyze mathematically, and then you take it to its fullest extremes and see what happens at the extremes. That's what real scientists do. Regrettably, it's what biologists rarely do.